all. Myself, Professor Prashant Mahajan, working as an assistant professor at AISSMS Institute of Information Technology. So today we are going to start NEET number 2, that is instrumental methods of analysis. So in that we are going to see three topics. That is first is electrochemistry, then pH metry, and then conductometry. So what is electrochemistry? So electrochemistry, it is the branch of the chemistry which deals with the interconversion of electrical energy to chemical energy and vice versa. So you can see it is the branch of the chemistry that deals with the chemical changes produced by electricity and production of electricity by chemical changes. So that means that is interconversion of chemical energy to electrical energy and vice versa, that is electrochemistry. So the word itself indicates that is electrical and chemical, so that is electrochemistry. Then next is types of cell. So there are two types of cell. One is holytic cell, that is also called as galvanic cell. Second is electrolytic cell. So difference is in holytic cell, chemical energy is going to convert into electrical energy. That means chemical reactions is going to produce electricity. The definition is a spontaneous reaction generates electrical energy, that is called as holytic cell. For example, battery. Then second is electrolytic cell, that is it absorbs free energy from the electrical source to drive a non-spontaneous reactions. That means electrical energy is going to convert into chemical energy. For example, rechargeable batteries. So the example is that when you are going to charge your mobile phone, that is the example of electrolytic cell. That means you are going to plug in the charger and you are going to store that electrical energy in the form of chemical energy. And when you are going to use that mobile phone after removal of charger, that is going to be operate on the voltaic cell mode. That means first you are going to charge, that is rechargeable battery, that is nothing but electrolytic cell, that is electrical energy is going to convert into chemical energy, and then while using reverse process takes place, that is chemical energy is converted to the electrical energy. So that is types of cells. So you can see in the diagram, first is the galvanic cell and second is the electrolytic cell. Then next is common components in the cell. So first is electrodes which conduct electricity between the cell and surrounding. So there are two types of electrodes. One is anode where oxidation takes place and second is cathode where reduction occurs. Second is electrolyte. So it is the mixture of ions involved in reaction or carrying charge. And third is salt bridge which completes the circuit and provides the charge balance. So that are the common components present in the cell. Next is representation of cell. So you can remember it as A, that is for anode, B for salt bridge, C for cathode. So always you write first anode metal or anode electrode, then anodic ion, then salt bridge, then cathodic ion, and then cathode. So in that way, Daniell cell representation is Zn/Zn plus 2, salt bridge copper plus 2 and copper. So that is the representation of Daniell cell, and in general you can write it as anode, anodic ion or anodic solution, then salt bridge, then cathodic ion or cathodic solution, and then cathode. So next is EMF of the cell. So it can be find out by using E cathode plus E anode. So E cathode, that is reduction takes place at cathode, and E anode means oxidation takes place at anode. So that is EMF of the cell. Then next is electrode potential. So electrode potential, it is nothing but the electrical double layer generated at the surface, metal surface and the solution. So you can see the definition. When a metal is placed in a solution of ions, the metal acquires either positive charge or negative charge with respect to the solution. Thus, there is a definite potential difference is developed between the metal and the solution. This potential difference is called electrode potential. So you can see the diagram here first. So this is a metal strip deep in the metallic solution. So metal has two tendency. First, metal can get oxidized in the solution as Mn plus, and n number of electrons will be present on the metal strip. So that is, electron will remain on the metal strip and ions will go to the solution. So in this case, there is a generation of electrical double layer that you can see, plus outside the metal strip and minus on the metal strip. So that is the one case, that is reaction A, that is oxidation of metal. Second is, see, a reverse of the first reaction, that metallic ions present in the solution, that is Mn plus, will take the electrons from the metal strip. That means negative charge on the metal will go to the solution and positive charge will remain on the metal strip. So that is also one type of generation of electrical double layer. So that is reduction. So reaction B is reduction, reaction A is oxidation. So when a solution, sorry, when a reaction A is greater than reaction B, then metal acquires negative charge. When electrode is negatively charged with respect to the solution, that is oxidation potential, that is it acts as anode. So that means when reaction E is greater than reaction B, this metal will get oxidized. That is called as anode. And in the reverse manner, that is when reaction B is greater than reaction A, that metal will get reduced, that is it will act as cathodic. So it is depend on the electrochemical series. Means what, if a metal has a less number of electrons in the last cell, then it will get definitely oxidized. That means, for example, sodium, potassium, calcium is there. So sodium has one electron, so it will get, or it will lose electrons and acquire positive charge. On the other hand, if we have zinc, same reaction will take place. Okay, so that is the oxidation. So that is called as oxidation potential. And if any metal get reduced, that is called as reduction potential. Our next topic is Nernst equation. So we are going to consider first reduction reaction. So that is Mn plus 2 plus n electrons will give you metal. So Nernst equation is E is equal to E0 minus 2.303 n RT upon Nm minus log of product side upon reactant side. So you can see this is the product side, so it is in the numerator, and Mn plus, it is the reactant side, so it is at the denominator. So what is R, what is T, what is F, what is N, what is E0, that we are going to see. So first, E0 is the standard electrode potential, R is the gas constant, T is the temperature, N is the number of electrons, and F is the Faraday's constant. So our gas constant value is 8.314 joule per Kelvin per mole. T is temperature, which is 25 degrees Celsius, which is nothing but 298 Kelvin. N is the number of electrons, that is depend on the reaction. F is the Faraday's constant, that is 96500 Coulomb. After putting all these values, we are going to get the equation, that is E is equal to E0 minus 0.0591 upon N into log of 1 upon Mn plus. So we are going to take concentration of metal as 1. So this is for the reduction reaction. If we consider oxidation reaction, same formula will turn into E is equal to E0 minus 2.303 RT upon NF log of product side upon reactant side, that is Mn plus upon M. So in that case, this formula is going to change like this. E is equal to E0 minus 0.0591 upon N into log of, this will go to the numerator and this will come to the denominator. So that will be log of Mn plus upon 1. So that is for the oxidation reaction. So that's it from today's lecture. Thank you.